So this is a shorter topic. Just to review the basic structure and bonding of amines. If you remember, amines have primary, secondary, and tertiary structures, and these can be abbreviated like this: primary, secondary, tertiary. Primary amines basically are an amine group connected to a carbon, but only one carbon group. The others, notice, are hydrogens. So an example of that is this compound, which is butyl N-butylamine, if you want to look into the naming. I'm not going to stress the naming of amines too much. You can sort of take them as we go along, time to time. A secondary amine then, likewise, using the same logic, is connected to two other carbons and has only one hydrogen. And so a compound like this would be a secondary amine. Carbon there, carbon there. And a tertiary amine has three carbons attached and no hydrogens. And this one would be called triethylamine. An amine with three ethyl groups. So the other thing to really notice about amines is they all have this lone pair, unless it has reacted in a certain way. So that dictates its reactivity. That lone pair is basic. It's a Lewis base, electron pair donor. So it can form bonds. And when you think about amines as being classic bases, the old Bronsted-Lowry base theory, that's true even though it's forming a bond. It's in those cases it's forming a bond to hydrogen. So it really is always a Lewis base, is the way to think about it. That those electrons can form a bond. And in the last unit we saw how they form bonds with carbonyl group carbons as nucleophiles. We'll touch on that again briefly. This chapter goes into a lot of nomenclature, which I'm not going to stress, like I mentioned. It does go into some of the reactivity of amines. I can point out some features of this. Basically, in section 16.5, I want to say, it goes through this series of types of reactions of amines. And, 16.5. And so, if you look at this progression here, we have an amine reacting with water, picking up a hydrogen. We have an amine reacting with base, but still doing the same thing where it picks up a hydrogen from the, acid, not base, excuse me, picks up a hydrogen from the acid. Here, it's a little different. It's giving up a hydrogen to a base. So, but all of these react in a similar way where it's forming a bond with that lone pair, displacing the pair of electrons that's here because hydrogen can only have one bond to it. Those electrons go on to the more electronegative oxygen. So you have this new bond being formed in orange. And then the oxygen has an extra lone pair of electrons and now it's negatively charged. The nitrogen, notice, is positively charged. So when you see a nitrogen with 4 bonds, it's going to be positively charged. When you see it with 3 bonds, like over here, it ought to have a lone pair of electrons and have no charge. In the second reaction, it really proceeds the same way. Bond forming, bond breaking, bonds being just pairs of electrons. And so we have the new bond forming in this compound here, the plus charge because the nitrogen has 4 bonds, and the acid has lost a hydrogen and is now neutral water. Finally, if we say, what is the continued reactivity of this species, for example? Technically, well, I'm not going to go into that. Sorry, strike that. So this can give up a hydrogen to go back to neutral. The difference here is that you're forming a bond from the hydroxide ion, displacing these electrons back onto the nitrogen, which is plus charge, so it makes sense electrons want to go in that direction. That's where those electrons end up. The hydroxide ion has picked up a hydrogen and is now neutral water. So basically, this is the reverse of the first reaction above. Notice, it's like the exact same reaction going backward. Basically, this is, no pun intended, amines acting as bases, except for the bottom one where it's acting as base, an acid, essentially, with a base, hydroxide ion. Okay. Really, a lot of that should look very familiar. We've seen these reactions before, for the most part. Finally, I just want to remind you that amines are well known to react as nucleophiles, in this case forming a bond to the carbonyl carbon, kicking electrons up onto the oxygen. That oxygen ends up with 3 lone pairs where previously it only had 2, so now it's a negative oxygen. The nitrogen, as we see above and right here, has 4 bonds, and so it has a plus charge. We know that this can continue with loss of a proton here and gaining of a proton here, and will likely end up looking like this. Not like that. Like that. Carbon, carbon, OH. So, and we saw a bunch of that in the last unit too. So that's just a reminder. Anytime you're talking about amines, it's not enough to just say they act as bases, like here. They also very commonly can act as nucleophiles, like we learned in the last unit.